Hi everybody, I didn't get a chance to finish everything I wanted to talk about in lesson 9-6, so I've decided to go ahead and do a little bit of a YouTube lesson for you to help you get that homework completed. I'm going to let you look at page 491 on your own and discover why all of the shapes that we're talking about so far in this chapter are called conic sections. You can look at how cones can be split apart and look at the cross section and figure out that conic section on your own. Also, I'm just going to do a really quick review about just sort of some general equations for circles, ellipses, and all the other conic sections that we've talked about. And if you think about it, I've simplified these even further just to make them really easy to look at. These are all going to be centered at 0, 0, just again to make them really, really easy to look at. Remember that a circle has the general equation x squared plus y squared equals r squared. R could be just about any number. But the big thing about a circle is that the coefficients in front of the x squared term and the y squared term are going to be the same. Also, with a circle, you have to have a plus sign between them. They have to be the same sign. And almost always, that's going to be a plus sign. It's just easier to look at it that way. Ellipses, again, have a plus sign. But in this case, ellipses aren't completely round. The radius isn't the same all the way around. So the value that we end up with under the y term is going to be the length of the radius in the y direction, and the value that we end up with under the x term will end up being the length of the radius in the x direction. Now remember, we can also talk about foci with radiuses, or foci with ellipses, and all of those other details. We're just skimming over things pretty quickly right now. And we can also have a hyperbola, which looks a lot like an ellipse, but instead of a plus sign, the hyperbola has a minus sign. Hyperbolas can open up and down, or left and right, depending on which of these is positive. If x is positive, it's going to open up and down. If y is positive, it's going to open left and right. And last, our favorite parabolas, which are going to have the general equation of y equals ax squared plus bx plus c. If a is positive, it's going to open up. If a is negative, it's going to open down. You can also solve for x, and you can get parabolas that open right when a is positive and left when a is negative. So those are just real down and dirty, the kinds of equations that we're going to see when we're talking about our conic sections. On this page, I'm showing you a little bit more detail of one of the definitions that we haven't really talked about a lot yet, but one of the definitions of a parabola. The important thing about a parabola, or one of the important things, and the one that we're really going to focus on today, is that the distance between the focus and any point on the parabola that we'll call xy is going to be the same. We're going to call that d1. That distance is going to be the same as the distance from that same point to the directrix, which is another line that we haven't talked a whole lot about when it comes to parabolas. So d1 for a parabola has to be the same for d2 for every single point on the parabola. That's one of the ways that we define a parabola. Well, hey, we're talking about distance, and you might remember something called the distance formula. If you don't remember it, let me give you a real quick heads up here. Distance formula is going to be equal to d is equal to x1 minus x2 squared plus y1 minus y2 squared. Well, if I'm talking about the distance between these 2 points, do you think that I can maybe use the distance to actually calculate what d1 is going to be? Well, sure I can. Let's pretend for this problem that the focus is at 2, 3. I know I kind of drew it so that it looks like it's right on the y-axis, but it doesn't really matter how I drew it. We just know that that focus is going to be 2, 3. We know that xy could be any single point along that parabola, anything. So I'm not going to give that point actual value. I'm just going to say, well, it could be any of those points, so I'm going to leave it as xy. And we can say that d1 is going to be equal to the square root of x minus 2 squared plus y minus 3 squared. And that's what D1 is going to be. Well, what about D2? If I know the equation of that directrix, and in this case I'm going to say that y is equal to a negative 7, that's going to be the equation of that line, can I figure out the distance between this point and the directrix? Well, I should be able to. If I'm talking about the distance between a point and a line, remember that that distance is going to be the shortest when we're talking about a perpendicular angle there. Well, if this is perpendicular to there, then I know that every point along here is going to have the y-coordinate of negative 7. Doesn't matter what x is, it's going to be negative 7. And if I'm talking about this point, then I know that the point closest to that point on the parabola is going to have the x-coordinate of x as well, because it's perpendicular. They have to have the same x-coordinate. And the y-coordinate of this point that is closest to the point on the parabola is going to be negative 7 because every y on that line is negative 7. So if I wanted to find D2, it's going to be the square root of x minus x squared, and you're right, that is going to simplify to 0, plus y plus 7. Because it's going to be y minus y1. Well, y minus a negative 7 is y plus 7 squared. So that's going to simplify to the square root of y plus 7 squared. And that simplifies even more because we're going to have D2 equal to the absolute value of y plus 7. Remember, when we're doing square roots, we only really want to take the positive value. So, well, what does that mean? Remember when I said a minute ago that for all parabolas, the distance from the focus to every point on the line, or on the shape, that distance has to be the same as the distance from that point to the directrix. So we know D1 has to be the same as D2. So we have x minus 2 squared plus y minus 3 squared equals the absolute value of y plus 7. Well, in order to simplify this, I am going to square both sides. So I'm going to end up with x minus 2 quantity squared plus y minus 3 quantity squared equals y squared plus 7y plus 49. Now remember, I only wanted the absolute value. When I square this, let me get it out so you can see, I only want the absolute value of this side, right? And when I square the absolute value, I'm going to get a value that absolutely has to be positive because it doesn't matter if a number is negative or positive. When you square it, it's going to be positive. So once I square it, I don't have to worry about the absolute value bars anymore because I know this is positive no matter what that was. Okay? So here we go. We've got some, well, it looks like we've got some algebra to do. Let's do a little bit more simplification. Let's boil this out so that we get x squared minus 4x plus 4 plus y squared minus 6y plus 9 equals y squared plus 7y plus 49. All I did was boil. Okay? Now let's subtract everything off. I need to rearrange a piece of paper here, so hold on. Get some blank paper under here. And I'm going to move this up to the top of the screen so we can see just that. I'm going to move all of the stuff from the right-hand side over to the left-hand side so that I can cancel off whatever might cancel. So what I end up with here is, well, there's no x squared term, so x squared minus 4x plus 4, y squared minus y squared is going to be 0. Negative 6y minus 7y when I bring it over is negative 13y. And 9 minus 49, I'm going to make that a negative 40 equals 0. Well, I can still combine these terms. And let's see what else is happening. Well, it looks like I don't have any y squared terms anymore, do I? I only have a y. So what kind of thing is going to happen here? Do you know? Let's simplify that a little bit more. Did I make a mistake anywhere? I had negative and negative. That's negative 13y. I think I'm good. So then I'm going to end up with x squared minus 4x. I can combine those, minus 13y minus 36 equals 0. Okay. Well, if I think about it, I don't have any y squared terms, so it can't be a circle or an ellipse or a hyperbola because all three of those require a y squared term. So this is very clearly going to be the equation of a parabola, which is going to open either up or down. And I can tell that just by looking at just this equation. It has to be a parabola. Okay? So I have a sneaking suspicion that I made an algebra mistake in here somewhere. Minus 6y. Da, da, da. And, oh, this should have been a 14. 14y, 14y, because when I FOIL this, I'm going to get 7y and 7y, so that should have been 14y, which when I bring it over here is going to be in minus 20y. So that's a minus 20 right there. Okay. So anyway, we can tell that this is definitely going to be the equation of a parabola, which we knew it was going to be anyway. But this is exactly the kind of method that you're going to use to solve a lot of your homework problems in the end of this lesson. So go ahead and try it yourself. Always be looking to find the distance, come back here, whatever the two distances are that you care about. In a lot of the problems, it's going to say, well, the distance between 2 points has to be 3 times the distance between another distance. So once you set that up properly in your homework, they should all just fall in place. And as you do your algebra, you will figure out what the equations are of your conic sections. Okay? I hope that helps. I know we will have questions in class, but go ahead, give it a shot, and let's see what we can do. Okay? Have a good time with your homework.